Greetings and welcome back. In this video, I want to take a high-level look at containerization and virtualization on Linux. This may be the first in a series of videos, I'm not sure yet, but this is going to be a high-level look. And if I do any future videos in this series, they're going to be on more specific items like Proxmox, VirtualBox, or VirtManager, which are a number of virtualization and containerizations ecosystems available in Linux. Just to be clear, I'm going to be playing somewhat fast and loose with the high-level look at virtualization. Yeah, I know some of the things I'm going to say are going to break down when you get looking at a lot of things a little closer, but from a high level, if you're the average Joe user, this should help you understand what's going on with a lot of the virtualization, containerization talk you'll hear almost everywhere nowadays. So this video is basically meant to provide a level of understanding when people talk about containerization and virtualization, especially for us average users who once upon a time weren't really familiar with it, but had to learn about it and tried to learn about it without all the jargon and technical terms. Initially, I wanted to cover these two topics separately, but whenever you mention containerization and virtualization, or vice versa, the other always comes up. So you're not going to have a virtualization discussion without containers, and you're not going to have a containerization discussion without virtualization. So I thought, hey, might as well cover them together and kill two birds with one stone, so to speak. Since this is a high-level look, as I said, when you get down to the lower levels, it's not going to be super accurate, but I basically am going to define three levels. Two of them are fairly well known. The third one I made up just because it suited me and I couldn't find anything really equivalent. If somebody knows, I hope they will leave a comment and let me know. But the first level is operating system containerization, which is your basic virtual machine. The second level, or the bottom level, is application virtualization, and we'll get into that a little bit. And the level I'm creating between operating system and application, I'm calling hybrid virtualization because it's, well, you're not virtualizing the entire virtual container, but you're virtualizing a whole lot more than a application. But I guess to get to it, I really need to define some of these terms and stuff. So that's a definite top priority in this video. So first, I'm using containerization and virtualization in the broadest sense of the terms. Basically, I'm considering anything that runs in any sort of container, sandbox, or isolated environment as being virtualized and fair game for this discussion. Full virtualization itself is relatively easy to define. That's operating system virtualization. That's where the whole operating system, the kernel, is set on top of virtual hardware, and the whole thing is a virtualization. So pretty straightforward there. So basically, we're defining operating system virtualization as the virtualization of the entire operating system and all applications running under that operating system in a single container. This is your classic virtual machine that you can set up with programs like VirtualBox or Proxmox or VirtManager, which works with QEMU and KVM. The hybrid version is where, yes, you're virtualizing an operating system, but not all of the operating system is in your virtual container. Examples are Linux containers or LXC, where the kernel is actually the kernel of the host operating system or the main operating system and is not located in your virtual container. These would be your hybrid types, and that would also include Docker and Podman at this particular level, although it's very broad in between the two container systems I mentioned already. Now, application containers, they would be strictly an application and any actual dependencies you need to run that application, but they would be running on top of an existing host machine or Linux installation. And all you're really virtualizing, containerizing, sandboxing is the application itself with the needed dependencies to get it up and running. Anyways, those are the definitions we'll be working with here. And one objection or complaint I'm probably going to get in the comments is classifying virtual machines as containers. Many people will say that containers are an alternative to virtual machines, and therefore we should not classify them together. I would argue, however, that a container is an isolated, standalone environment, including all dependencies necessary to run it, and I think with that definition, a virtual machine definitely fits into it. Not that it really matters, because we're going to cover them all anyways. And regardless of your viewpoint, the fact is that virtual machines generally always mentioned, just like containers and virtualization mentioned together, virtual machines are also generally mentioned in the same breath with the others. So it just makes sense to do them here as well. So to be upfront, I have not used every virtualization ecosystem under Linux, so I'll probably not get the examples in this video, but when I do, they will be with ones that I'm familiar with. And again, I think I've already said the list a couple times. I'm familiar with Proxmox, VirtualBox, VirtManager with QEMU and KVM. I'm also familiar with Docker and Podman and Linux containers and Flatpaks and Snaps, which also fall under this. Oh, and Appimages, although I'm not quite as familiar with Appimages. I do want to be clear that I'm not making any recommendations on what you should or shouldn't use. Your workflow, your experience will be different from mine. I pretty much use Linux as my main driver now. I haven't logged into Windows in a couple of months, so I actually went and deleted that off my laptop there. But if you believe the statistics, only 4 or 5% of the desktop market actually uses Linux. So odds are, if you're watching this video, you're using maybe Windows, maybe Mac, I don't know, maybe even Unix. So as I said, what works for me under my Linux environment may or may not work for you under whatever operating system you're using. Best advice: understand the benefits of any of the various ecosystems. Also understand their issues. They all have their own set of problems as well as advantages, so you just need to be aware of them. I'd suggest going out and using a bunch of them and finding out the ones that actually meet your use requirements and going with that. That's the best advice I could give you now. Okay, let's start talking about terms and jargon, or definitions, if you will. We got a few of them to get through here, so we're all on the same page. So first one I want to talk about is hardware. This is your actual physical computer. I guess technically the case is hardware, but this is more of your motherboard, your graphics card, your hard drives, your memory, things like that, your mouse, your keyboard, things like that. We're going to be talking a lot about a host computer, and this refers to your computer. Your computer as the host, as it is sponsoring any virtual machines. So when we say host, we mean the computer, the operating system that is actually running on the hardware that the virtual machine will be running on, not the virtual machine, the actual computer. Operating system is another term we use, OS for short sometimes. Just beware, somebody says OS, capital OS, they generally mean operating system, but this manages your computer hardware. It's what you install to get your computer up and running, whether it's Windows, Mac, Linux, Unix, whatever. It's, again, the operating system. It's what makes your computer run. It manages your computer's hardware, and it manages the software, including all the applications installed. The kernel is part of the operating system. In fact, it's pretty much the heart of the operating system, or some people would say the brain of the operating system. The kernel, and there can be different styles of kernel. There's a hybrid kernel, there's a monolithic kernel. You have kernel modules, which are basically drivers for various hardware, and then there's kernel modules that are basically for things like virtualization on the computer. But all communication with the software to the hardware goes through the kernel. So that is your, again, heart or brain, however you want to look at it, of your operating system. Now we're going to use the term hypervisor, and this is what creates and manages your virtual machines. There are two types of hypervisors. A type 1 hypervisor is either part of the kernel or runs directly on the kernel. There's no other operating system involved. In fact, it would be the de facto operating system. That's a type 1 hypervisor. A type 2 hypervisor runs on top of your operating system. As we get along, we'll talk more about the distinctions, but for example, KVM, which is a kernel module for creating virtualization, resides in the kernel, so it's a type 1 hypervisor. QEMU, on the other hand, rides on top of a KVM. It's in that gray area where it might be type 1, might be type 2. I've heard it referred to as both ways. Something like VirtualBox is a type 2 because it rides definitely on top of the operating system. Virtual hardware. This is something I don't hear talked about a lot, but it's there. Virtual hardware is what your hypervisor creates for your VM or virtual machines operating system to run on top of. It doesn't run on top of the real hardware. But it does have to have a hardware interface. So a virtual software one is created by your hypervisor. A guest refers to your virtual machine, your container, your sandbox, whatever you want to call it. It's referred to as the guest. Your host system is your main computer. Any subsystem, virtualization container running on it is a guest. Application, again, this one's probably self-explanatory, but it's any software not part of the OS that performs a specific function. Apache Web Server is an application. PHP, even though it's programming language, is also an application. So is LibreOffice. Again, anything running that's not really a direct part of the operating system is an application. Pass-through is another term you're going to hear quite often. This refers to actually passing physical hardware through to the virtual machine. Probably the most common example of this is passing through USB ports, so that when you plug a USB device into a port on your host, it will be passed directly through to your VM so it can look at it directly. Another common thing to pass through would be the graphics card. There are some limits on pass-through, and there's things to be aware of on pass-through, but yeah, it's basically passing real hardware through to the virtual machine instead of virtual hardware it runs on. Okay, that's our basic definitions. I'm sure there's some I've forgotten, but let's go ahead and move on. Okay, let's talk about virtual machines specifically. This is probably the easiest to understand, so we'll start out with you've got your computer or your host computer's hardware, and running on top of the hardware is your actual host computer. I'm making a distinction because we're delving into the software realm here, but your host and your hardware is your computer, but I want to make a distinction between the two. Now, running within the host, you have your kernel modules, kernel drivers, what have you, depends on the type of kernel you have, communicating with your hardware. On top of your kernel, you have your operating system. This is your host operating system. Again, Windows, Linux, Mac, Chrome OS, whatever. You have an operating system that runs on top of your kernel. And I'm not going to go into breakdowns of an operating system, but basically it allows communication between the applications and the kernel to the hardware and back. Now, since we're talking about virtual machines on top of the host operating system, we have a hypervisor. Since this is on top of the operating system away from the kernel, this is a type 2 hypervisor. If this was a type 1 hypervisor, we would remove the host operating system, and the hypervisor would just drop down right on top of the kernel. So what your host or your hypervisor is going to do is going to virtualize some hardware that you need to run your virtual machine, and you're going to, well, through the hypervisor, you're going to give it certain resources to use, a number of cores from CPU, amount of memory, disk space, things like that, and then it'll create, the hypervisor that is, will create your virtual hardware. And your guest is going to run on top of this virtual hardware. This would be a virtual machine or guest as opposed to the host. And of course, the guest is going to have its own kernel because this is a full virtual machine. It's going to have its own operating system. And you could, through your hypervisor, create multiple guests as long as you don't run out of hardware resources, because each virtual machine is going to require a set amount of dedicated resources. So we could technically, if we have the resources available, create a second guest. One thing to keep in mind when creating guests or virtual machines, you got to remember that you need some of the resources for your operating system or your host. This is, well, we'll talk about this when we talk about other ways of doing this, but this is one of the drawbacks of virtual machine is that, yes, it requires dedicated hardware, be dedicated to that machine. And of course, in each virtual machine, guest 1 can have guest 1 applications running, and they're isolated from the host and from guest 2. Guest 2 has its own applications running. So again, depending on what you're doing with each guest and what you're doing with your host and how much resources you have. But this is technically 3 separate computers, 2 virtual machines, and 1 host or actual hardware computer. And this type of computer is basically your virtual machine. Now, as I said, virtual machines require dedicated resources, but what if we could take the kernel from your guest machine? Let's say we're running a Debian 12 host and we're going to run a Debian 12 guest. Well, then technically they're using the same kernel. So guest 1, we could take the kernel and remove it and just run directly from the actual host kernel. Same with guest 2 if it was running Debian 12. You can do this depending on how similar your systems are. For the most part, it should work. I mean, if you run Fedora on top of Debian or Arch, you may run into issues. Maybe not. But this also implies that your guest is running a similar operating system to your host, so you can use the host kernel. And the advantage, one of the big advantages here is you're only assigning hardware to 1 kernel, and it can delegate which guest gets how much resources depending on what it needs at the moment. This would be Linux containers or LXC, Docker, Podman. You notice I replaced the hypervisor with a container engine, and again, this is going to depend on your container what this engine actually is. Now, when you get down to the details, there are some differences, so this is just a high-level overview to understand that when you're running, but it's modified from, it's not a full virtual machine because parts of the machine are still running on the host. However, the parts that are running on the guests are still isolated. Now, if you're actually running, you can technically run your applications in their own sandbox container, and then the host operating system and the kernel are all part of the host machine, but each application is running independently in its own sandbox. Sandbox does contain the application, but it also will contain any dependencies needed by the application that may or may not be met by the operating system. This is sort of like, well, this is like Flatpak, snaps, or app images. And again, basically is better utilization of resources while still running your applications in an isolated environment or a sandbox. So that's basically the, at that level, we're pretty much, like I say, applications isolation. You're going to find this sort of stuff a lot in atomic or immutable distributions where they're actually running the OS as a container and they're running the applications as containers. Okay, that's our high-level look at containerization and virtualization. My hope is that I've been able to provide for the average user some insight into containers and virtual machines and the various ecosystems on the, well, not necessarily the ecosystems, but just understanding the various concepts of virtualization, containerization on Linux. So in this video, I have endeavored for the most part to try and stay away from specifics. I'm also aware that my presentation here may not fit perfectly with many implementations there are out there, especially, like I say, when you get down into the weeds, things might not be quite as I highlighted them in the video. As I said, this is just the hope of this video is for a high-level understanding of the overall virtualization and containerization ecosystem and what's available out there. Now, I also don't want to make it sound like I'm saying containerization and virtualization is the end-all for every computing need. They have their place, but again, they're not the end-all. And as I said, every single ecosystem you see out there has its own advantages and disadvantages, so it behooves you to do your research. If I do a follow-up on this video, I'm guessing I'm flipping a coin between VirtualBox and VirtManager, but I think since I'm using VirtManager at this point in time, that's the way I'll go. Again, don't know if I'll do a follow-up or not. If there's enough interest, yeah. Although I may do one just because I want to do it anyways. We'll see. Regardless, if there are follow-ups, they will be a lot more weeds-oriented than this video, not so high level, and they'll be covering a specific product and specific ecosystem. But that's for the future. So, as always, like, comment, subscribe, let me know what you're thinking, and we'll see you next time.